going to talk about randomness and natural tendency. Another word for randomness is the word entropy. Entropy is a measure of the randomness disorder in a system. The law of disorder says that systems in nature will tend toward disorder or chaos. We see this all around us our whole entire lives. If you imagine driving on the road, if there weren't any laws or any rules or any signage, you would probably have complete and utter chaos, and everyone would drive into each other, get accidents. You also see this in your backpack. If you're not really careful to keep organization, all of a sudden you got papers all over the place, same thing in your bedroom. So it's very clear to us that any system that's left naturally on its own will tend toward randomness unless we force it to not be so random. What does this have to do with chemical reactions? This is actually a driving force in a chemical reaction. So this will actually affect whether or not a reaction is likely to happen. Systems in nature are going to want to tend toward increasing entropy or being as random as possible. Systems in nature are also going to tend toward lower energy. Please keep in mind that lower energy equals higher stability. So what a system is trying to do is it's trying to go to a low energy stable state, but it's also trying to be as random as possible. So let's look at a couple of examples. If we put salt into water, what's going to happen naturally, whether or not we stir that mixture, is the salt crystal that we start with, which is highly organized, okay? So this has very, very low entropy, is going to be dissociated or broken apart by the water molecules and begin to float randomly around the solution. So we're going to end up in a situation where we have a lot more entropy since those particles are randomly dispersed throughout the system. If we had, some ice or some water that we left out, so if we have ice or water, it would probably start in a more organized fashion. If this picture is probably most likely depicting ice that looks pretty locked into place, so maybe we have an ice cube, and that's going to end up turning into liquid water because it's going to tend toward randomness. There's some other energetics there, but it's the same basic idea. Where this ties into what we're doing now, remember, we have these initial energy steps that we have to do in a reaction. So we might actually start a reaction by putting in some energy. So this was our initial endothermic step. This exothermic step happens naturally on its own. And the reason that that happens is this system wants to give away energy. Remember, bonds forming is exothermic. The products of those bonds forming are more stable than the things they started as. These guys up here in this high energy state, we had to put them here by making them break apart, break their initial bonds. When they're in this high energy state up top, they actually are very unstable. So it is the tendency of things in nature to want to get to a more stable state. When bonds are formed, we have those nice stable octets, and our molecules are much, much happier. So since this is going to be more stable and at a lower energy state, the natural thing that systems in nature want to do is tend toward that nice stable state, so systems will give away their energy.